Chirality, the hidden handedness of nature. Chirality, often called handedness, is a fundamental property of nature that explains why certain molecules, like those in our bodies, behave differently even when chemically identical. It's why your left and right hands are mirror images but not interchangeable, and why this seemingly abstract concept has profound consequences for biology, medicine, and even the evolution of life. The basics of 3D structure at its core, chirality describes objects that cannot be superimposed on their mirror images. This isn't just a visual quirk. It arises from the three-dimensional arrangement of atoms within molecules. A molecule might contain the same ingredients, chemical formula. But if those ingredients are arranged differently in space, the result can be dramatically different. These variations are called isomers, and they can range from harmless to highly toxic. Why handedness matters in biology. Living organisms almost exclusively use one hand of certain molecules. Amino acids, the building blocks of proteins, are a prime example. Nature favors left-handed amino acids. This isn't random. It likely emerged early in life's history and became fixed through evolution. Why? Because biological systems, like enzymes and receptors, are themselves chiral. A left-handed amino acid fits into a right-handed binding site like a glove, while the mirror image won't. This specificity is critical for chemical reactions and proper function. Implications for health and medicine. The importance of chirality extends to medicine. Many drugs are chiral, meaning they come in two forms, one that heals and one that does nothing or even harms. The infamous thalidomide tragedy is a stark example. One isomer relieved morning sickness, while the other caused severe birth defects. Bacteria, fungi, and even our own immune system rely on chiral recognition to identify and neutralize threats. The ability to distinguish between left and right-handed molecules is key to how our bodies fight off germs and maintain health. From DNA to digestion, chirality everywhere. Chirality isn't limited to proteins. DNA, the blueprint of life, is a chiral molecule. The way it spirals dictates how genetic information is stored and replicated. Even seemingly unrelated processes, like digestion, rely on chiral enzymes to break down food effectively. The concept influences everything from how our bodies process glucose for energy to how plastics degrade in the environment. Understanding chirality is essential for designing new materials, developing targeted therapies, and unraveling the mysteries of life itself. The unknown future. While we've made strides in understanding chirality, many questions remain. Why did life select one hand over the other? What role does it play in the origins of disease? As we continue to probe the molecular world, chirality will undoubtedly remain a central theme in the ongoing story of life's complexity.